How is it going, ladies and gentlemen? This is the Wolf Around, and it's great to see you here. In this video, I'll show you how to quickly compile GLFW from its source code on Linux. GLFW is an open source, multi-platform library written in C. It provides a simple API for creating windows, contexts, and surfaces, as well as receiving input and events. Subscribe to the channel, join the pack, you are always welcome here. Without further ado, let's get started. Creating a window is one of the most crucial parts of developing a game engine. In other words, being able to compile the library you'll use to create a window is essential for having full control over it. I've written a batch script to automate this process and make it easier to explain. The script will check for required dependencies one by one. If a dependency is missing, it will install it. Confirm whether the GLFW source code has already been downloaded. If it hasn't, it will download it. Ask which CMake generator you want to use, Ninja or Unix makefiles. Ask whether you want to compile GLFW as a release or debug build. Ask which build type you want to choose, static or shared. Configure the CMake arguments. I've enabled the necessary options and disabled unnecessary ones, such as examples and tests. Optimize the compilation process. The script detects your computer's maximum thread count and uses 2 fewer threads for compilation. Start the compilation process. Now let's open a terminal in the same directory with the script and run it. Since all dependencies are already installed on my system, the script didn't prompt me to enter my sudo password to install missing dependencies. If there are any missing dependencies, it will prompt you to enter your sudo password. After checking the dependencies, the script downloaded GLFW's source code. Now I'll choose Ninja as the CMake generator. I'll compile it as static release. Compilation is complete, and the library output directory is here. Next, I'll compile it as shared release. Compilation is complete, and the library output directory is here. Now I'll choose Unix makefiles as the CMake generator. I'll compile it as static debug. Compilation is complete, and the library output directory is here. Next, I'll compile it as shared debug. Compilation is complete, and the library output directory is here. I'm a software engineer specializing in computer graphics, game development, GPU hardware acceleration, AI inference, and cross-platform C++ development. I look forward to sharing more insights with you. Please like, subscribe, and leave a comment. I'll see you in the next one.